Alright guys, as promised, we'll be doing a second code-along exercise in C# today where we'll be focusing on writing a code an algorithm, I guess, that takes a set of curves that you plug into it. These green ones being curves that have multiple directions, etc., and the order might be all over the place. And what our algorithm or algo is going to do is make these all have the same direction, and then it's also going to sort them around a curve. Now you can do this with flip curve and sort curves along curve as well, but I just thought that I was interested in writing it in C# just to see how what the workflow would be and how long it would take, and I'm going to share that learning experience with you. So without further ado, let's drop a C# component down onto the canvas. And we'll rename X to curves, make that a list access, I'm definitely sure of. So plug that in. Oh, and we're going to declare that they are in fact curves. Y will be sort curve, I think. Cool. Item access for that one, and it's also going to be declared a curve. And so we'll go ahead and plug those in. So the workflow that we're going to follow is let's start to create some container lists, list geometry for not geometry. List for for what we create to be added to. So we're going to add a list of point 3Ds, and we'll call that new curve start. So this will be the list that contains our new start points. Oh, that always happens. Beautiful. And we also want to do the same thing. Curve. Create a list of curves, and we'll just call it, I don't know, B for now. That's bad practice, but it's late at night. It's not really that late at night, I'm just old. And it's done that again. Why didn't I just do this at the start? Cool, sorry, the autocorrect is a pain in the ass. Let's start to do our alignment computation. So what we want to do is align all the curves according to a sample curve we'll just take out. So we'll write a for loop that goes, for every curve in this collection, if for each subsequent curve, if the direction matches the first curve, don't do anything to it. If it doesn't match it, if it's flipped the other way, reverse it, and then put it into a list. And if it did go the same way, put it in the list as well, but just don't reverse it. So this is what that looks like. For int I equals 0, and then I is less than curves.count. So this is how we write the for loop in C#. Let's do that. Open her up. Curves I dot reverse. Oh, I need an if statement in there first. So what we're going to say is if curve dot do directions match curves, we'll take the 0th one, the first one, and curve I. Yep, that'll be great. So if that, now what that's going to do is if the directions match, it's going to return a true or false. So we're going to say if it equals, we'll go do it this way first. If it equals false, we're going to, oh, so many spaces. Curves dot reverse. Cool. And then we're going to go, then we'll add it. So that'll reverse it, and then we will add it to our new list of curves. Like so. Oh, I forgot a bracket. And then I'm just going to copy this down. If it equals true, if curves do directions match equals true, we're going to do the same thing, but we're just not going to reverse it. Make sense? Great. Oh. Okay. Awesome. So now we're going to get comparison points. This is an easy one. For this is another for loop. For int I equals 0, and I is less than b dot count, and then we'll increment, chuck some brackets down, I reckon, and then we'll go new curve start dot add b I dot point at start. So I've typed it. What it's going to do for every curve I, so for every curve in curve of b dot count, which is like 6 or something, it's going to add it's going to take every curve in B and take a point at start, and it's going to add that to a list that we created up here called new curve start, and that list of course is of points, and that is also a point. Cool. So what do we got going on? Expected to close bracket on line 95. Oh, I think that's because of that. So line 93. Nope. Line 78. That seems right. That one. I'm missing a close bracket. And where am I? Oh, okay. Well, I've jumped the gun here a little bit. I need to add a close bracket there and turn that into an else if statement. Cool. And then this one and this one. Alright guys, what I realized is I'm going to get rid of this one, and I do believe in my haste to get to write this down in a short amount of time for you guys, I forgot to add a bracket there. And I've also been slack with my writing, typing. I think that's it. Curves. 63, 73. Oh wow, it's all throughout it. 63, 73. Should have just called it curve. Cool. So we're good to go. So what we're going to do now is we have a whole bunch of points that we're going to sort around. So a whole bunch of points in new curve start that we're going to sort around this curve. So I'm going to use like closest point, which it's a method that requires like a curve to find out the closest point. It needs a double, like it needs a double made for it to it's going to go, oh, this is the parameter at the closest point. So we'll just make that now, and we're going to call it an out double. And it's just going to be empty for now. And then we're also going to create some arrays for sorting. So arrays are similar to lists in that they're containers for things, but they're a lot more strict. You've got to type them out like this. New curve. This one b dot count. Oh, and probably half wrote equals. And I'm going to make another one as well while I'm here, except it's going to be a double. Oh, like that. I'll call it something like that. New double. Cool. So an array is similar to a list, right? That's how you write a list. Here we go. That's how you write a list for a curve. That's how you write an array for a curve. But an array, it can't get bigger or smaller. It's a set amount. And the reasoning behind that is if you use an array when you know how big it's going to be, but because you already know how big it's going to be and program that into it, it generally runs a lot quicker in terms of computation. So now we're going to compute closest point to curve. And we're going to go for, and remember our brackets, int I equals 0 and I is less than b dot count. Start increment over to I. There's those two brackets that we've already done already. And now we're going to go sort curve dot, which is what we have before. And then we go closest point. And we're going to go new curve start for I. And then we're going to go out t. And we're going to go 0, semicolon. And then what we're going to do now is format it a little bit and go IC I equals B. Let me just type this down and explain it a bit. TAI equals T. So what we've got is so finding the closest point on sort curve from closest point on sort curve to new curve to the ith in new curve start, and that's going to give us the parameter that comes out. So we're immediately going to stick that parameter into here and tell the double array called TA, so that the ith version is that, and the same thing for the curve. So we're going to tell the curve array that the ith is the ith curve in B. So this will make a lot more sense when we start to actually sort it now. So let's do that. Form sorting operation. And what we're going to do is, it's really quite easy, array sort TA and IC, and then A equals IC. So what that is going to do is, it is going to sort our curves, our curves that we want to sort in IC, by all the doubles that are in TA. So the doubles that are in TA are the parameters on this curve that's closest to these ones. And then what we're going to do finally is spit it out. Oh, and let's see what kind of bug testing we're going to do. The T does not exist in the current context. That is because I said I was going to create the double, but I actually didn't do it. And there we go. Oh, I do have to remember to flatten that geometry coming in. And it seems to have worked. So let's have a look if it's right. So firstly, I know we've got 6 curves here. Firstly, let's grab them. If we have a look here, the endpoints are start and end. And up here, oh, now they're all facing the right way, which is good. And let's have a look and see if they all match up. 0, 1. Oh, we're having a little bit of an organizational problem. 0, 1, 2, 3, 4, 5. I know what this is. I think I just need to change. We're going to go for the first curve that we put in. Really should have specified that one a bit more. There we go. And I think this should work now. 1, 2, 3, 4, 5. There we go. It was just the curve that we chose to sort everything by. 1, 2, 3, 4, 5, 6. Because the curve that we happened to sort everything by happened to be a curve that started over here, so it flipped all the curves over there as well, and then when it went to do that sorting operation, things were a bit weird. If I recompute that, it's computing pretty quickly. Probably, one more thing we could build in is to check that thing at the start, or maybe we can sort along that original curve there, but it's only 20 minutes and you're all probably C-sharped out for now. Keep sending me your codes, keep posting it. Again, with these tutorials, I am not a computational design wizard. I'm kind of, delving into C-sharp all that myself and sharing it with you guys. So please ask me to clarify what isn't clear, and I'll aim to do that. But also just keep trying this stuff out on your own. Stay cool.